this is Geometry, Unit 10, Lesson 6. The rest of the notes about rectangles. Okay, so we have just done all the proofs of why rectangles are rectangles. So we now have proved there's 3 ways of proving a quadrilateral is a rectangle. So, first way, the quadrilateral is equiangular, which means all angles are congruent. If you have a quadrilateral where all angles are congruent, that means that there's 360 degrees in a quadrilateral. If you divide that by 4 equal angles, that's going to be 90-degree angles, which makes it a rectangle. So if you can prove that the quadrilateral is equiangular, you can say it's a rectangle. Okay, now you can also say the quadrilateral is a parallelogram with a right angle. All right, all you have to prove it's a parallelogram because opposite angles are congruent. If opposite angles are congruent and you have a right angle, and then the consecutive angles are supplementary, those would also have to be 90 degrees. So if you can prove it's a parallelogram with one right angle, you can say it's a rectangle. This is the most common way of proving a rectangle. You first prove it's a parallelogram and then say it has one right angle. That's all you have to do. And then the third way is because of the properties of a rectangle. It's a parallelogram with congruent diagonals. That's what makes it special from just a regular parallelogram. A parallelogram doesn't have congruent diagonals, but a rectangle does. So if you can prove it's a parallelogram that has congruent diagonals, you can say it's a rectangle. Okay, let's try this out. Determine if each of the following is a rectangle and give a reason. Okay, well, first of all, based on the diagram that we have here, we have both pairs of opposite sides are congruent. What does that make it? Well, if both pairs of opposite sides are congruent, that makes it a parallelogram. So that makes it a parallelogram. So now we know this is a parallelogram. So let's look at our definitions up here. If we can prove it's a parallelogram with a right angle or a parallelogram with congruent diagonals, we're all set. So, well, does this have a right angle? Yes, it does. D is a right angle. So that means a parallelogram with a right angle is a rectangle. So this one is yes. This is a rectangle. So first we had to prove it's a parallelogram. It is because both pairs of opposite sides are congruent. And then it has one right angle, so that makes it a rectangle. Okay, let's try the next one. Okay, let's look at the next one and see how we do on this one. All right, so we have this figure over here, A, B, C, D, and then we have these arrows being parallel. So what do we know about opposite sides parallel? Well, if both pairs of opposite sides are parallel, what does that make? It makes it a parallelogram. Both pairs of opposite sides are parallel, so that means this is a parallelogram. So we know ABCD is a parallelogram right now. Okay, now what we need to know next is, do we have either congruent diagonals or one right angle? Well, we only have one diagonal here, so we can't figure out if it's congruent or not. However, we can try to figure out the measures of the angles. Okay, now if these lines are parallel, these two lines are parallel right here, these right here, that makes the transversal, the line right here. What kind of angles are formed by parallel lines cut by a transversal? Well, alternate interior angles are, aren't they? So if this angle up here is 25, this angle down here is going to be 25 as well because of alternate interior angles. Okay, now, what is the measure of angle D? Well, the whole angle D would be this whole angle right here, is going to be 65 plus 25. If I add those two angles together, I get angle D. Angle D will equal 90 degrees. What kind of angles are 90 degrees? It's a right angle. Okay, so angle D is a right angle. So that means a parallelogram with a right angle is a rectangle. Is a rectangle. So that means yes, this is a rectangle because we proved it. Okay, let's do the last one. Okay, so our last one here, we have our diagram ABCD, where AC and BD are congruent. So that means the diagonals are congruent. Is this a rectangle? Okay, actually, there's not enough information. Okay, what we do know is the diagonals are congruent, which is good in a quadrilateral, but what don't we know? Well, remember the definition says if we have a quadrilateral with congruent diagonals, it's got to be a parallelogram. So in order for this to work, we have to prove that we have a parallelogram. So right now, we don't know if this is a parallelogram. It could be. We don't have enough information to say that. We don't know if the opposite sides are parallel, the opposite sides are congruent, or the diagonals bisect each other, or the opposite angles are congruent. We need more information. So we can't say, yes, this is a rectangle. We would have to say no until we get more information. So if you want to use congruent diagonals, you have to prove it's a parallelogram first. So since we don't know if this is a parallelogram or not, we can't say this is a rectangle. We can just say it's a quadrilateral with congruent diagonals. Okay, so that is all the properties of a rectangle and how to prove what a rectangle is.